Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Physics Chapter 8 Current Electricity. We will be discussing the topic Electrical Energy and Power, which is the last session of this chapter. Hope you all are ready for the session. Let's start. First, let us understand what is electrical energy. Electrical energy word we have been using in the chapter work, energy, power. We have studied the different forms and the different forms of energy and the conversion of energy. Energy can neither be created nor be destroyed but can only be changed from one form to another. This is the statement of law of conservation of energy. We have studied this. So here you can see some devices. There are many devices where electrical energy is getting converted into different forms of energies. So we know that in case of an electric heater, in case of an electric toaster or an oven, what is happening? Electrical energy is getting converted into heat energy. Okay, here what happens is there will be a filament. In this case, it is a nichrome filament. So this nichrome filament, when the electricity passed through the nichrome filament, it started getting heat up. Okay, heating of this nichrome filament is producing the heat energy that is required to cook the food. Okay, now when you take the case of an electric lamp, in electric lamp we know that the electrical energy is getting converted into light energy. Okay, here we have the tungsten filament. This tungsten filament starts to get heating up. Okay, and heating up of this tungsten filament helps in the glowing of lamp. Okay, now when you take the case of a fan, in fan what is happening? We know that the electrical energy is getting converted into mechanical energy. So there is a coil which is connected to the axle. Okay, when this axle rotates, what happens? The coils start to get heating up. The motors coils start to get heating up and helps in the rotation of the blades of the fan. Okay, now here you can see a soft iron which is wounded using a wire. Okay, let us say it's a copper wire. It is connected to a battery. When connected to a battery, what happens? Charges starts flowing, electricity starts flowing. So here the electricity or the electrical energy is getting converted into magnetic energy. Getting converted into magnetic energy, and this soft iron can become an electromagnet. So this is what is happening. So electrical energy is a form of energy that we are using daily. Okay, it is being converted into different forms and we are using it. How to find the electrical energy or how to measure the electrical energy? Let's see, here we have a circuit. So in this circuit you can find a key, a resistor, a battery, and a current is flowing. That is, from the positive terminal you can see the current flowing through the circuit due to the movement of electrons. So here you can see this current will pass through the resistor R. Okay, now when the key is plugged in, the current starts flowing. Okay, we are going to find how to calculate the electrical energy. We know that when this current flows due to the presence of charges. Okay, and we have current I is equal to Q divided by T. Okay, we have studied this. Current I is charge per unit time. Okay, from this, how much charge flows can be calculated. The charge will be equal to the current into the time. Okay, current into time will give you the charge. We have studied that what is potential difference. Potential difference is a work done in moving a charge from one point to other. Okay, it is a work done. Okay, so we have potential difference V is equal to W divided by Q. Amount of work done in moving the charge from one point to other. Or we can say the work done will be equal to potential difference into charge Q. Potential difference into charge Q. Okay. Now, here this work done will be the electrical energy. Okay, this work done is the electrical energy. You can either represent it as W or you can represent it as E. We will be having E is equal to or W is equal to V into Q. So this is your first equation. Now from this we can replace Q with IT. Okay, Q is equal to IT. Therefore, if I am representing this as the first equation, from equation 1, when you substitute here, you will be getting electrical energy E is equal to V into IT. Okay, so this is your second equation. This is equation A. To find electrical energy when you know the charge and the potential difference. In most cases, charge will not be given, current will be given, current and time will be given. In that case, you can use this equation. Okay, this is equation B. Now to get the third equation, you are going to use Ohm's law. V is equal to IR. So in this equation, in place of V, we are going to substitute IR. Okay, electrical energy E is equal to, in place of V, put IR. Then you have an I into T. I into T. E is equal to, I into I is I square RT. E is equal to I square RT. Okay, so this is your third equation. Electrical energy E is equal to I square RT. To get the fourth equation, we are going to replace in place of I. We are going to change I. To get the third equation, we have changed V. To get fourth equation, we are going to change I. Okay, what is I from Ohm's law? You will be having I is equal to V divided by R. Substituting here, you will be getting E is equal to VIT. In place of I, put V by R. E is equal to V into V divided by R into T, which is V square T divided by R. Electrical energy is equal to V square T divided by R. Okay, the fourth equation, E is equal to V square T divided by R. First equation can be used when potential difference and charge is given. Second equation can be used when potential difference, current and time is given. Third equation can be used when current, resistance and time is given. And the fourth when potential difference, time and resistance is given. Clear? Okay. So these are the equations. Electrical energy supplied by the source E or W is equal to Q into V, VIT, I square RT, V square T divided by R. Okay. Next is electrical power. We have studied about power. What is power? Power is the rate of doing work. Work by time will give you power. So here electrical power can be defined as the rate at which the electrical energy is supplied by the source. Here the work done is the electrical energy. It is the rate at which the electrical energy is supplied by the source. The same circuit you have a battery. The current flows through the circuit when the key is plugged. Okay. Now we'll be studying the expressions for power. We have power is equal to work by time. Here it is the energy supplied. Energy supplied divided by time. Okay. Or the work divided by time. Now what is work? We have studied potential difference is the work done in moving a charge from one point to other. Okay, V is equal to W divided by Q, and from which we have W is equal to V into Q. Same thing that we have used in the previous part. So W is V into Q. Okay. V Q divided by time. So here we have the first equation for power. Power P is equal to QV divided by T. QV by T. Now to get the second equation, we have current I is charge divided by time, and charge Q will be current into time. Current into time. Okay, substituting here, we'll be having power is equal to V into IT. In place of Q, I am substituting IT. V into IT divided by T. T gets cancelled. Okay, therefore power P is equal to VI. So this is your second equation. Power P is equal to VI. Second equation to find power. Here, when potential difference and current is given, you can find power. Next, the same thing we are going to apply Ohm's law. According to Ohm's law, V is equal to IR. So in order to get the third equation, we are going to substitute in place of V, IR. Okay, power P is equal to IR into I, which is equal to I square R. Power is I square R. Okay. This is your third equation. Power P is equal to I square R. Equation 3. Now equation 4. To get equation 4, here we have replaced in this equation in place of potential difference IR. Therefore, we will be having I is equal to V by R. So, to get the fourth equation, in place of current, we are going to replace V by R. Power P will be equal to Vi, which is equal to V into V divided by R, which is V square divided by R. Power is equal to V square divided by R. This is your fourth equation. Okay. In first equation, we are putting Q by T is equal to I. To get the third equation, what we are doing? The second equation replacing V with IR, and to get the fourth equation, in the second equation replacing I with V divided by R. This is how you can find power. So power P is equal to work by time, or the electrical energy supplied divided by time, which is equal to potential difference into current, or the square of potential difference divided by time, or the square of current into time. Now, what are the units of electrical power? We know power is work by time or energy by time. Power is equal to W by T. From this, what do we get? What do we get the unit of power? What is the unit of work done or unit of energy? Energy, it is joules, and that of time is seconds. Joule per seconds or joule second inverse is 1 unit. Then the next unit of power we are getting is equal to V into I, which is volt into ampere. Okay. Therefore, volt ampere is one other unit of power. Now we have a standard unit. Standard unit of power, or the SI unit of power, is watt, represented by WATT, represented by the letter capital W. This is a unit of power. SI unit of electrical power is watt. Okay. Now how can you define 1 watt? So here we have 1 joule of work done for 1 second, or the potential difference when it is 1 volt, the current flowing if it is 1 ampere, then you will be getting a power equal to 1 watt. Okay, 1 watt power is obtained when 1 volt of potential difference is across the battery and the current flowing through the circuit is 1 ampere. We can see 1 watt is the electric power consumed when a current of 1 ampere flows through a circuit having a potential difference of 1 watt. Okay. Now we have bigger units. We have studied smaller units and bigger units. Here we'll be using the bigger units more of that of power. So here 1 kilowatt. What is 1 kilowatt? 1 kilowatt is 10 raised to 3 watts. Then 1 megawatt, 10 raised to 6 watts. And 1 gigawatt, 10 raised to 9 watts. So these are the units of power. Units and the bigger units of electric power. Commercial unit of electrical energy. What is the unit of energy? We have studied unit of energy and unit of work is the same. Joules is the unit of energy. Okay. We know that electrical energy is power into time. Okay. Power into time is energy. How did you get this? We know that power is rate of work done. Okay. Work done by time. Then work done will be equal to power into time, and this work done is the energy. Electrical energy is power into time. W is equal to P into T. Then what is the unit? Unit of power, we know it is watts, and the unit of time is seconds. Watt second is a unit of power. Now, when it comes to commercial unit, that is in your daily life, we'll be coming across other units of electrical energy. These are watt hour and kilowatt hour. Okay, so power or the electrical energy will be expressed in watt hours and kilowatt hour. When you check an electrical bill, okay, when the electric bill, next time when you get the electric bill, you can see that this much units of power consumed, this much units of energy, electrical energy consumed. Okay, so here the units used will be the watt hour and kilowatt hour. Now let's see what is watt hour. 1 watt hour is the electrical energy consumed by an electrical appliance for 1 power 1 watt when it is used for 1 hour. Power should be 1 watt and the time it takes is 1 hour. We know that electrical energy is equal to power into time. Okay, power into time. What is power? Here given that the power is 1 watt. 1 watt into time is 1 hour. Okay. 1 watt hour will be 1 watt into 1 hour. What is 1 hour? 1 hour is equal to 60 minutes and we know 1 minute is 60 seconds. Therefore, 1 hour will be 60 into 60 seconds. 60 into 60 seconds. Then how much do we get? 1 watt hour will be equal to 1 watt into 60 into 60, 3600 seconds. Okay. Then this will be equal to 3600 watt second. 1 watt hour is equal to 3600 watt second. So this is the relation. Okay. Watt second, another unit is joules. So we can say that 1 watt hour is equal to 3600 joules. Okay. Joules is a SI unit of energy, or joules is a SI unit of work. Now what is kilowatt hour? This is a bigger unit. 1 kilowatt hour, represented as kWh, is electrical energy consumed by an electrical appliance of power 1 kilowatt when it is used for 1 hour. Okay. Here again we have electrical energy is equal to power into time. Power into time. Okay. Here the power is 1 kilowatt power. 1 kilowatt into 1 hour. Let's convert. What is 1 kilowatt into watts? 1 kilowatt will be 1000 watts. Okay. And we have 1 hour is equal to 3600 seconds. Clear? Therefore, the electrical energy will be equal to 1000 watts into 3600 seconds. Okay. Here you have 1, 2, 3. 3 zeros. Here 2 zeros. You will be getting 3, 6 and 5 zeros watt second. Or this can be written as 3.6 into 10 raised to 1, 2, 3, 4, 5, 6. 6 watt seconds, or 1 kilowatt hour is equal to 3.6 into 10 raised to 6. Watt second is joules. So this is the second relation. 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joules, and 1 watt hour is equal to 3600 joules. So next time when the electric bill comes, you can just check it. And this kilowatt hour, 1 kilowatt hour is also called 1 unit. So 1 unit current will be 1 kilowatt hour of electrical energy. Clear? Power rating of common electrical appliances. So when you take some bulb, on the bulb or on the cover of the bulb, you will be given 100 watt, 220 volt. So this is the power rating, and this is the voltage rating of that particular appliance. Okay. When the power rating and voltage rating is known, you can calculate two important things. The first one is the resistance of its filament or element when it is in use, and the second is the safe limit of current which can flow through the appliance while in use. Let's see how to calculate this. We have studied some relations for power. Power P is equal to V into I, equal to I square R, equal to V square divided by R. Okay. Now, if you need to find the resistance, we have to take a relation in which resistance is included. Okay. We know the power and the voltage. Voltage rating we know. In that case, voltage, power and resistance. So, this relation can be used. Okay. We'll be having power is equal to V square divided by R, which means it is equal to the voltage rating of appliance square divided by resistance. Will be giving you the power rating of the appliance. In that case, we can find the resistance. Resistance will be equal to voltage rating of appliance square divided by, taking this power to the denominator, which is the power rating. Power rating or the power rated on the appliance. Okay. Now in this case, we have 100 watt power and 220 volt potential difference or voltage. In that case, what is the resistance? We can calculate the resistance. R is equal to V square 220 square divided by 100. 220 into 220 divided by 100, cancelling zeros. 22 into 22, 484 ohms. Okay, so this is the resistance of the filament wire that is being used. Next, the safe limit of current which can flow through the appliance while in use. What is the safe limit? Above this, if the current flows, there are chances for the device to get damaged or the appliance to get damaged. Here what happens is, above this, if the current flows, then the fuse, the appliance may get fused, that is a wire, the tungsten filament or any filament that is being used may get melted up. Okay. Due to this melting, the device may not work properly or it gets damaged. How to calculate the safe current? Let's see how to calculate. You need a relation connecting current, voltage and power. Which is the relation? Here you have power is equal to I square R. Okay. And we have power is equal to V into I. We need V, I and P. So this relation, P is equal to VI, which means safe current I is equal to P divided by V. Okay. Safe current is equal to power rated on the appliance divided by voltage rated on the appliance. Okay, here in this case 100 divided by 220. What is 100 by 220? When you calculate, you will be getting 5 divided by 11, that is equal to 0.454 ampere something. When you round it, you will be getting approximately 0.5 ampere. Okay, below 0.5 or equal to 0.5 ampere current, when it flows through the circuit, there is going to be no problems. But if the current exceeds 0.5 ampere, then there are chances for the filaments to get heated up and it starts melting. The device may not work and it will be getting damaged. Clear? So this is how you can calculate the resistance and the safe limit of current. Okay. Household consumption of electrical energy. So have you checked the electrical meter? So here we'll be having an electric meter at your home. So this electric meter measures the amount of electrical energy consumed by the various appliances in the house in a given period of time. Okay. So here you will be given how much units of energy you have consumed. When you check an electric bill, the units will be given and also the amount is given. So this amount comes not by using just a single device. Okay, in a house you will be having lamp, you will be using bulb, then you will be using television, you will be using washing machine. Okay, then what else? You will be using a fridge, iron box, fan. So all these devices consuming electrical energy, that too in different amounts. The power rating and voltage rating of all these devices is not going to be equal. They are different. So when you have this much unit of energy consumed in a given month, it means it is because of all these. Okay, depending on the power and the voltage rating of these devices. When you take the sum of all these, you will be getting the total energy that is consumed. At 2 in units. Okay. Now 1 unit is equal to, as I said, 1 kilowatt hour. 1 unit is 1 kilowatt hour. So if you are expressing the electrical energy in kilowatt hour, usually it is expressed in kilowatt hour. It means the power is taken in kilowatts and time is taken in hours. Okay. Power in kilowatt and time in hours. Now, if you need power in watts, then it will be equal to power when taken in watts and time when taken in hour. Then you will have to divide by 1000 to get the electrical energy in kilowatt hours. Because we know the relation, 1 kilowatt is equal to 1000 watts. And 1 watt will be 1 by 1000 kilowatts. Okay. Now, if you know the voltage and current, in that case, how to determine? We know power is voltage into current. Okay. Voltage taken in volts and current taken in amperes into time taken in hours whole divided by 1000 will be giving you the electrical energy in kilowatt hour. Okay. Electrical energy in kilowatt hour. For example, let's say there is a device. For example, let us take a case of an electric bulb. So, electric bulb is consuming some 15 watts of energy. Okay, and this device is being used for 3 hours. Just a simple calculation, 3 hours per day. Okay, so in 1 day, what is the electrical energy that is consumed? It will be equal to 15 watt into 3 hours, which is 45 watt hours. So in 1 day, 45 watt hours. If you are considering a month of 30 days, in 30 days, the single device will be consuming 30 into 45 watt hours of energy. Yes, 30 into 45 watt hours of energy. And what is it equal to? This will be equal to 1350 watt hours. Okay, so for the single device, 1350 watt hours of energy is consumed, or this is equal to 1.350 kilowatt hours of energy consumed. Now, if I say for 1 unit energy, its rate is rupees 2. Okay, 1 unit energy, 1 unit of electric energy is available at rupees 2. Then what is the total cost for only a single device? The single device, how to calculate? You will be getting the total cost equal to electrical energy consumed into cost of 1 unit. This is a case of a single device that we are discussing now. Okay, electrical energy consumed into cost of 1 unit. In this case, you will be getting 1.350 is the electrical energy consumed into 2 rupees. That is equal to 2.70. Okay, rupees 2.70 just for a single device. Okay, so if you know the power and how much time each device is being used, then you can calculate the total electrical energy if you have many devices. Okay, 1, 2, 3, 4, 5. If you have 5 devices whose power is taken as P1, P2, P3, P4, P5, and the time it is used. The first device 41 hours, second 42, third 43, fourth T4 and fifth T5. In that case, you can calculate the electrical energy equal to P1 T1 plus P2 T2 plus P3 T3 plus P4 T4 plus P5 T5. So this will give you the electrical energy, and then this electrical energy after calculation multiply with the cost of 1 unit, you will be getting the total price or the total cost. Okay, heating effect of electric current. We have studied that because of electric energy, what is happening? There is heat produced in most cases. In conversion of electrical energy into light energy, in case of a bulb, we can see that some amount of this electrical energy is getting converted to heat energy, which is a wastage of energy. So we are going to study the heating effect of electric current. But this heating effect is going to be useful in some devices. For example, in case of electric oven, in case of microwave oven, then heaters, in all these devices, what is happening? The useful heating energy is obtained. Okay, the amount of heat produced in a wire on passing current through it depends on 3 factors. We have studied that when electrical energy is passed through a wire, it starts to get heated up. Okay, in some cases, when more current flows, it starts to melt and the device may get damaged. Now, what are the factors on which this depends on? The heat energy depends on. The first factor is the amount of current passing through the wire. Okay, current I. How does it depend? Let's see. If heat energy is represented as H, then heat energy will be directly proportional to the square of current. Okay, heat energy directly proportional to the square of current. When current increases, heat energy also increases. Now, the second factor on which it depends is the resistance of the wire. Okay, resistance R. When heat energy is to be determined, if you know the resistance value, when it increases, the heat energy will also increases. They are also directly proportional. Heat energy directly proportional to the resistance of the wire used. And the third, the time for which the current is passed in the wire. How much time the current is passed. Again, heat energy directly proportional to time. Okay, then combining all these 3, you will be getting heat energy directly proportional to I square, heat energy directly proportional to resistance, heat energy directly proportional to time, which means H directly proportional to I square RT, or you can write, you are taking a constant, which constant here is equal to 1, then H is equal to I square RT. This is how you can calculate the heat energy that is produced in a wire. When you know the current value, the resistance value and time, you can calculate the heat. For example, let us take a current of 2 ampere flows. The resistance of the wire is 2 ohm and time in seconds is 2 seconds. In that case, what is the heat energy? Heat energy will be equal to I square. 2 square, R is 2, time is 2. Okay, 2 square 4, 4 into 2 8, 8 into 2 16. So heat energy is 16 joules in this case. This is how you can calculate the heat energy. Clear? Okay, so remember one important thing. Heat energy, we know it, you get it in joules. If you need heat energy in calories, 1 calorie will be equal to 4.18 joules. Okay, so here you are getting it in joules. To get it in calories, what should be done? You will have to divide I square RT should be divided by 4.18. Then you will be getting the heat energy in calories. Okay, heat energy in calories is I square RT divided by 4.18 calorie. Or you can write this as 1 by 4.18 into I square RT calories. So if you calculate this, then heat energy will be equal to some 0.24 I square RT calories. Okay, so you will be getting the heat energy in calories by multiplying I square RT with a value 0.24. Okay, if in the question they are asking you to find the heat energy in calories, or else you can just write the heat energy what you get in joules. Joules law of heating. We have studied a relation to find heat energy. H is equal to I square RT, or heat energy is directly proportional to square of current, resistance and time. If you are taking the current in amperes, resistance in ohms and time in second, you have a statement, and this statement shows the relation of heat energy with current, resistors and time. And this is called Joules law of heating. Amount of heat produced in a conductor is directly proportional to the square of current, directly proportional to the resistance and directly proportional to the time for which the current flows through the resistor. So this is a statement. Just nothing. You just need to know this relation. H directly proportional to I square RT. Heat energy directly proportional to square of current, directly proportional to the resistance and directly proportional to time. You will be getting the Joules law of heating. Just study this statement. Okay. Let us take an example. A voltage source sends a current of 2.5 ampere to a resistor of 20 ohm connected across it for 5 minutes. Calculate the potential difference of the source. Second, the electrical energy supplied by the source. And third, the heat in calories produced in the resistor. So first, what are the given quantities? Here we have current I given. I is equal to 2.5 ampere. Resistance of the resistor is given. R is equal to 20 ohms connected across it for 5 minutes. Time is given. Time is in minutes. 5 minutes. So we have to convert it into seconds. Okay. So 5 minutes is 5 into 60 seconds, which is equal to 300 seconds. Okay. So the first step we have to calculate the potential difference. Potential difference we have to find. How to find potential difference when current and resistors is known? We have Ohm's law. According to Ohm's law, V is equal to IR. Just substitute the values. Here I, current is 2.5 ampere and the resistance R is 20 ohm. 2.5 into 20. What is 2.5 into 20? You will be getting 50 volts. So 50 volts is your potential difference. Now the second part of the question, we have to find the electrical energy supplied by the source. How to find electrical energy? Again, for energy, we have studied equations. It is power into time. It is equal to VIT equal to I square RT equal to V square T divided by R. Which equation to use? Here we have current, resistance, time and potential difference known. Okay, VIT can be used, or you can use I square RT, or you can use V square T divided by R. Any of these equations can be used to find the electrical energy. So electrical energy is equal to, we'll use this equation VIT. Here V is 50, I, current I is equal to 2.5 and time is 300 seconds. When you calculate, you will be getting 3.75 into 10 raised to 4 joules. Okay, 3.75 into 10 raised to 4 joules is your electrical energy. Now the third part of the question, we have to find the heat in calories produced in the resistor. In calories we have to find. Okay, so we know that 1 calorie is equal to 4.18 joules. Okay, then what is 1 joule? 1 joule will be 1 by 4.18 calories. Okay, so here we have 3.75 into 10 raised to 4 joules, which means the heat energy will be equal to 3.75 into 10 raised to 4 joules, which is equal to 3.75 into 10 raised to 4 divided by 4.18 calories. So when you calculate this, you will be getting 9 into 10 raised to 3 calories. Okay, 9 into 10 raised to 3 calories is the heat energy. Okay, you can find like this, or you have studied another formula, that is directly you can find the heat energy. Heat energy H is equal to 0.24 I square RT. Just substitute the values. 0.24 into I square. Current is 2.5 square. Resistance is 20 and time is 300. Okay. So when you calculate this, again you will be getting the same value, 9 into 10 raised to 3 calories, almost equal to 9 into 10 raised to 3 calories. Clear? Second example, an electric kettle is rated 230 volt, 1000 watts. What is the resistance of its element when in use? Second, what is the safe value of current that can pass through its element? We have to find the resistance and safe value of current. Given the potential difference, V is equal to 230 volt. Then power P is equal to 1000 watts. A part of the question, we have to find the resistance of its element. How to find resistance? A relation that connects power, potential difference and resistance. What is the relation? We have power P is equal to V square divided by R. Okay, power P is equal to V square by R, which means resistance will be equal to V square divided by P. What is V square divided by P? 230 into 230 divided by power 1000. Okay, 23 into 23, we will be getting 529. Then 2 zeros divided by 1000. Here we have 1000. So cancelling the zeros, and here we have a point, which means 52.9 ohms. Ohm is the unit of resistance. So the first part is clear. Now the second part of the question, B part, we have to find the safe current. How to find safe current? Take the relation connecting power, potential difference and current. P is equal to VI, which means current I is equal to P divided by V. Okay, power by potential difference. Here power is 1000 divided by potential difference is 230. So when you calculate, you will be getting 4.35 ampere. If a current above 4.35 ampere flows through the circuit, flows through the appliance, and what happens? The electric kettle will get damaged. Okay, so below 4.35 or 4.35 is okay. This is a safe current. Third example, two bulbs A and B rated 100 watt 120 volt and 10 watt 120 volt respectively. They are connected across a 120 volt source in series. Calculate the current through each bulb. Which bulb will consume more power? These are the two questions we have to answer. Okay, here we have two bulbs which are connected in series. In series connection, we know that the current will be same, potential difference will be different. Okay, to find the current, first we have to find the resistance value of each bulb. Okay, how to find resistance? Here for bulb A, what is given? In case of bulb A, the power is given. Power of bulb A is equal to 100 watt. Then potential difference of bulb A is equal to 120 watt. Okay, how to find resistance now? We have power is equal to potential difference square, V square divided by R, which means R of A will be VA square divided by P, VA square. 120 into 120 divided by 100. Cancelling zeros, 12 into 12, 144 ohm. Okay, resistance of bulb A is 144 ohms. Now for bulb B. Bulb B, we have power of B is equal to 10 watt. Then potential difference of B is equal to 120 volt. Okay, again RB will be equal to VB square divided by PB. Okay. VB square 120 into 120 divided by PB is 10. Zeros getting cancelled. 12 into 12, 144. Again we have a 0. So 1440 ohms. Now what is the total resistance? This is series connection. In series connection, the total resistance, this is RA, this is RB. Then RS in series connection will be RA plus RB. Okay, RS total resistance will be RA plus RB. Now put the values. What is RA? RA is 144 plus RB is 1440. This is RS. Okay, when you add them, you will be getting 1584. So this is the total resistance. We know the potential difference. Potential difference across the battery, the potential difference is given, which is 120 volt. The question, we have to find the current through each bulb. In each bulb, the current flowing will be same because they are connected in series. Okay, therefore current I will be equal to, using Ohm's law, V is equal to IR. Therefore I is equal to V divided by R. Here V divided by RS. 120 divided by 1580, 12 by 158. When you calculate, you will be getting 0.08 amperes. Okay. So 0.08 amperes is the current that flows through both the bulbs A and B. Okay. Current flowing through bulb A and bulb B is equal to 0.08 amperes. Now the second part of question, which bulb will consume more power? Okay, which bulb is consuming more power? Here check the resistance. Resistance value, we know that resistance of A is less than the resistance of B. Okay, we have a relation, power is equal to I square R. Okay, now power of A will be I square RA and power of B will be I square RB. We can take this relation because in both these cases the current is same. Okay, current value is same, which means PA proportional to RA and PB proportional to RB. That is, when power increases, resistance value also increases. So here, in which case the resistance is less, the same case power will also be less, which means therefore power of bulb A is less than power of bulb B. Here we have to find in which bulb or which bulb will consume more power. Therefore we have bulb B will consume more power. Clear? Understood? Example 4. Calculate the electrical energy in kilowatt hour consumed in a month in a house using 2 bulbs of 100 watt each and fans of 60 watt each. If the bulbs and fans are used for an average of 10 hours each day. Second part, if the cost per unit is rupees 4.50, calculate in part A the amount of electric bill to be paid per month. First we have to calculate the total electrical energy that is consumed for a month. Okay, here what is given? We have 2 bulbs and 2 fans. So first we'll find the power for 2 bulbs will be equal to, here what is the power of one bulb? 100 watts. So 2 bulbs, 2 into 100, which is 200 watts. Okay, next power for 2 fans will be equal to, again 2 into 60 watt, which is 120 watts. Okay, now what is the total power consumed? Total power will be equal to 200 plus 120, which is 320 watts or 0.32 kilowatts. When watt is converted to kilowatt, you will have to divide by 1000. So this is the total power. Okay. Now what is the total electrical energy? Total electrical energy will be equal to, it is power into time. Here, what is the total time? If electrical energy is total power into time. What is the total time? Per day 10 hours and 1 month means 30 days. Okay, so 30 into 10 hours, which is equal to 300 hours. Okay, time is 300 hours. Now, the total power we have, we can find the total electrical energy. Electrical energy will be equal to 0.32 into 300, which is equal to 0.96 into 100, which is 96 kilowatt hour. Okay, electrical energy, total electrical energy that is consumed for a month will be equal to 96 kilowatt hour. Now the second part of question, B part, if the cost per unit is rupees 4.50, it is for 1 kilowatt hour, the price is rupees 4.50. We have to find the cost for 96 kilowatt hour, which is equal to 96 into 4.5. 96 into 4.5 can be written as 96 into 9 divided by 2. 4.5 is 9 by 2. Cancelling. This is 48. 48 into 9. 48 into 9 you will be getting 432. So rupees 432 is the amount of electric bill that is to be paid. Okay. Let us now do some problems from 8C. Problem 1. An electric bulb of resistance 500 ohm draws current 0.4 ampere from the source. Calculate the power of bulb. Second, the potential difference at its ends. So here, what is given? We have the resistance given. Resistance R is equal to 500 ohms. Then current I is equal to 0.4 ampere. Okay, so first part of the question we have to calculate the power P. How to find P? What is the relation? We have power P is equal to work by time is equal to VI equal to I square R equal to V square divided by R. Here we have resistance and current given. Resistance and current. So you can use this one. Power P is equal to I square R. Substitute the values. I square current value 0.4 square, and then the resistance is equal to 500 into 500. 0.4 square is 0.16 into 500. So in order to remove this decimal, you can take this 2 zeros, becomes 16 into 5, and that is 80 watts. So the power is equal to 80 watts. Now the second part of question, we have to find the potential difference between its ends. How to find the potential difference? Take the relation. We have power P is equal to V into I, which means V is equal to P divided by I. Here the power we have determined is 80 divided by current is 0.4. Okay. 80 divided by 0.4, which is 800 divided by 4, and that is equal to 200 volt. So 200 volt is the potential difference. Okay. Problem number 2. An electric bulb is rated 220 volt, 100 watts. What is its resistance? Then what safe current can be passed through it? We have to find the resistance and the safe current. Here given that the power P is equal to 100 watts. Then potential difference V is equal to 220 volt. Okay, first part we have to find the resistance. How to find resistance? Resistance R. Okay. We have power P is equal to VI equal to I square R equal to V square divided by R. Here we have power value given. Then we have the potential difference V given. We have to find resistance. So, potential difference, power, resistance relation. So, this one will be used. P is equal to V square divided by R. Then what is the resistance? Resistance will be equal to P divided by, resistance will be equal to V square divided by P. Okay, put the values. V is 220 square divided by power is 100. Okay, therefore resistance R will be equal to 220 into 220 divided by 100, cancelling zeros, 22 into 22, which is 484. 484 ohm is the resistance value. Now the B part of the question, we have to find the safe current that can be passed through it. How to find safe current? Consider a relation. Here we can take power is equal to potential difference into current. Then current will be power divided by potential difference, which is equal to power is 100 divided by potential difference 220. Cancelling zeros, this becomes 5 divided by 11, which is equal to 0.454. Thus you can round it up to 0.45 amperes. So this is a safe current. Above this current when passed, the device may get damaged. 0.45 is your safe current. Third problem, a bulb of power 40 watt is used for 12.5 hours each day for 30 days. Calculate the electrical energy consumed. So here we have the power given. Power is in watts. P is equal to 40 watts. Then time is given. T is 12.5 hours. Okay, it is consumed for 30 days. We have to calculate the electrical energy consumed. First, we'll find the electrical energy consumed for 1 day. Electrical energy consumed for 1 day will be equal to power into time. Here, 40 into 12.5. What do we get? 12.5 into 40. 12.5 into 4 is 50 and a 0. So 500. What is the unit? Unit of power. Power is taken in watts and time in hours. Okay, remember the unit. It is 500 watt hour. Electrical energy is 500 watt hours. Okay, now this electrical energy is being used for 30 days. Therefore, electrical energy consumed for 30 days will be equal to given value, that is the value which we have got from power and time, 500 watt hours into 30. Okay, 3 into 5, 15, then 3 zeros. So 15,000 watt hour, or you can convert this, we have 1 kilowatt hour is equal to 1000 watt hours. Okay, therefore 1 watt hour will be 1 by 1000 kilowatt hours. So here 15,000 watt hours will be equal to 15,000 divided by 1000 kilowatt hours. 15,000 divided by 1000 kilowatt hours, which is equal to, cancelling zeros, 15 kilowatt hours. Therefore, the electrical energy that is consumed for 30 days will be equal to 15 kilowatt hours. Okay. Problem 4. Two bulbs are rated 60 watt 220 volt and 60 watt 110 volt respectively. Calculate the ratio of their resistances. We have to calculate the ratio of their resistances. So here, first let's take the bulb A. In case of bulb A, power PA is equal to 60 watts and potential difference VA is equal to 220 volt. Next, for bulb B. For bulb B, we have power PA is equal to same thing, 60 watts, and potential difference VB is equal to 110 volt. Okay, we have to find the ratio of the resistances of bulb A and bulb B. What is the resistance of bulb A? RA will be equal to, we have power P is equal to V square divided by R. Therefore, RA will be V square divided by P, VA square divided by PA. Put the value 220 square divided by 60. Okay. Now, what about RB? Resistance of bulb B will be equal to VB square divided by PB, which is 110 square divided by 60. Okay. Now the ratio. RA divided by RB will be equal to 220 square by 60 whole divided by 110 square divided by 60. Okay, taking the reciprocal and multiplying, we get 220 into 220 by 60 into 60 divided by 110 into 110. Okay, 60 gets cancelled. 110 into 2 is 220. 110 into 2 is 220. 2 into 2, 4. Denominator 1. Therefore, RA is to RB. Ratio will be equal to 4 is to 1. 4 is to 1 is the ratio. Clear? Problem 5. An electric iron is rated 220 volt 2 kilowatt. If the iron is used for 3 hours daily, find the cost of running it for 1 week if it costs rupees 4.25 per kilowatt hours. So here we have the power given. Power P is equal to 2 kilowatt and daily it is being used for. Time is equal to 3 hours. Okay. Therefore, we can calculate the electric energy consumed in 1 day will be equal to power into time. Power is 2 kilowatt into 3 hours, which is 6 kilowatt hours. Okay, 6 kilowatt hours is electric energy that is consumed in 1 day. How many days we have to find? We have to find for 1 week, 7 days. Okay, therefore electrical energy consumed for 1 week will be equal to 7 days into 6 kilowatt hour, that is 42 kilowatt hours. Okay, so the total electrical energy that is consumed for 7 days is equal to 42 kilowatt hours. We are given that for 1 unit the price is 4.25. Okay, for 1 kilowatt hour or 1 unit the price is rupees 4.25. Okay, here we have 42 kilowatt hours. 42 kilowatt hours, the price will be equal to 42 into 4.25. Okay, when you multiply, you will be getting 178.5. Okay, so this is the total cost, rupees 178.5. Okay, that's all for today. In today's class, we have studied about electrical energy and power. We have studied the consumption, household consumption of electrical energy, and the commercial units of energy. Also, we have solved problems related to it. Hope you all enjoyed this session. I'll be back in the next session with a new chapter. Until then, stay tuned to LearnoHub. LearnoHub free hai par best hai. Thank you.